XJRunner integration gives you the ability to use boundary scan testing in your own code. It provides a way to call tests and programming tasks that were created within XJDeveloper, ready for XJRunner's use. In this short video, I'll show you the basics of how to use XJRunner integration in a .NET programming environment. I'll do that with some C# examples, but the principles apply to other .NET languages too. There are also equivalent videos for LabVIEW and TestStand users, and you can find those later in the series. Also, don't forget that XJ integration has two elements. In this video, I'll concentrate on XJRunner integration, leaving XJAnalyzer integration as the focus of the next one in this series. Whichever integration you're using, before you can run a test, you need to initialize an XJ link to establish communication. You do this with the getXJLink method. You either pass in an unsigned integer for a specific controller's serial number, or pass in nothing and leave the software to use the first XJ link it finds that's not in use. There's now a short sequence to follow. Along with initializing your XJ link, you need to load the project that contains your tests. Once those have been done, you can create a runner instance to gain access to the methods that will run your tests. Let's look at those steps in detail. When opening a project, you need to supply the path to a project file. You could use XJDeveloper's XJD project file if you've got an XJDeveloper license, but that's normally only useful during project development. After the design has been released for first production, I would recommend you work with an XJPACK file instead. That's the file exported from XJDeveloper. Using it means you'll be working with something that isn't going to change unexpectedly if someone updates the project without realizing you're using it. To load the project that contains the tests you want to run, create a runner project object and pass the path of that project file into the constructor. You now need to create an object of the runner class, so call runnerproject.getRunner and pass in details of the XJ link you initialized. This is a good time for me to explain about the project's test list. When the tests were created in XJDeveloper, they were added to the test list, but they were also given settings that determine whether they run by default or not. When you use the tests via XJRunner integration, you have choices. You can run the test list as it stands with those default settings, or you can override the settings so that it will run either all the tests, a different set, or just one individual test. Let me show you those different options. You always need to start with the runnerproject.getTestList method to get a test collection object. That object will represent the test list with its default settings. Then, to run all the tests that were originally enabled, you use the runTests method on your runner object and pass in that test collection. If you want to override the default settings, you can use methods from the test collection class. For example, you can use selectAll to run to override the defaults and set the whole list of tests to run. Or you can use selectTestGroup and pass in a string for a group's name to enable that specific group of tests. Or there's deselectTestGroup, which allows you to stop a group from running. Once you've changed the defaults in this way, you can then use runTests as before to run the modified test collection. You can also choose to run just one specific test. What you can see in this example are 3 tests in the group called RS485 tests. And let's say we just want to run the first one. You still have to start by getting the full list using the getTestList method as before to know what tests are available. This time though, you follow it by calling the method called testFunctionByName on the test collection and passing in 2 strings, the first for the name of the group and the second for the title of the test itself, in this case u4.test. That will return a test function object that you can pass to the runTest method on your runner object. The result is to execute just that one named test. And note, it's run test singular without an S at the end. There can be times when it's useful to set conditions on tests or a group of tests so they only run if certain criteria are met. For instance, there's obviously no point trying to program a memory if the test on it just failed. So when you create a test list in XJ Developer, you can set a condition that will control whether a group of tests will be run. It's evaluated just before the group is due to be executed, and if it returns false, the tests aren't performed. Conditions use XJEase functions such as hasPassed and hasRun, and are represented in XJRunner and XJDeveloper by a question mark, like here in this test list. When XJ Integration runs the test list, it'll obey these criteria by default, but you can override them by using methods of the condition class, such as override, which stops the condition being evaluated. And there's one additional point to be aware of. If a test has conditions that require another one to have passed first, then using run test to execute it in isolation isn't going to work. So watch out for that. Either use run tests so you can run both tests, or use override to disable the condition. As an aside, that's also a good reason for including the hasRun function in any conditions that rely on another test. It avoids a runtime error if you try to use hasPassed on a test that hasn't run. So far, I've been talking about running tests like this one here, but I should explain that there's also a way to run any functions that underlie those tests. Let me demonstrate that with an example. This is the file ledtest.xje. Running its test function using the runTest method will execute the complete test and return a pass-fail result. However, within this code, there are some underlying functions that it uses. For example, this one is called setLED, which simply switches the LED on or off depending on what value is passed in. Using XJRunner integration, you have the ability to call these individual functions, provided they're globally accessible. To do so, you can use run function instead of run test, and pass in strings for the name of the device you want it to operate on and the name of the function to use, along with its input and output arguments. As an example of when you might want to do this, think about the situation when you need to use external equipment to check an LED's colour and intensity. You couldn't use the LED test we just saw because that returns a pass or fail based on whether the LED is flashing rather than on a result from external equipment. However, you could use the underlying function we looked at to switch the LED on while you make your measurements, and then call the function again to switch it back off. Run function provides that ability. So XJRunner integration is very versatile, giving you total control over what tests or functions are run. So far, the methods I've spoken about execute a test and don't return control until it has finished. However, you might have occasions when you want to trigger a test and then do something else before it has completed. For example, you might want to display a progress bar during a long test. In that case, you need to use methods on the runner class called startTest and startFunction instead, which give back control after the test starts. Of course, you'll need to know when it has finished executing, so you have to use it in conjunction with the waitForCompletion method. A word of warning though, only use the start commands instead of run when you have a valid reason, because they do lead to more opportunities for mistakes. Once all your tests on that particular board have finished, don't forget to dispose the runner instance so that your project's global variables get reset before you start with the next board. Then, when you've finished all the testing that uses that particular project, you can dispose the runner project instance, and finally dispose the XJLink instance. Only use xjtagsystem.close right at the end once you've finished with all the equipment. That will do some final cleanup to ensure all the threads that XJTag created are stopped. I hope what I've shown you so far has given you a good introduction to integrating XJRunner into your .NET applications. To help you further, the default XJTAG installation includes several C# examples that you're free to copy and modify for use in your own code. You'll find them all in the xjintegration.net examples folder, which is normally in the XJTAG directory that's in your public documents folder. One demo file is the Windows Forms example. It includes an implementation of message boxes to display prompts and capture input from an operator, and shows you how to display test output formatted like XJRunner. That file is a useful reference if you need to include user interaction in your code or want advanced formatting. There's also extensive XJRunner integration documentation in the XJTAG help system. Go to the XJ integration section and you'll find the deployment entry that describes the steps that must be performed when using XJRunner integration in a .NET project. Then there's the API reference section. XJTAG.integration namespace describes the classes that are common to both XJRunner integration and XJAnalyzer integration. And XJTAG.integration.XJRunner namespace describes those that are unique to XJRunner integration. In the next video in the series, I'll show you how to use XJAnalyzer integration, which gives you the ability to control individual pins on a JTAG device directly from your code. I hope you'll join me for that as well. Thank you for watching this video. If you found it helpful, please subscribe for more and leave a like or a comment below.